Am I audible? Hello, everyone.
Yes, yes. Morning, Surendra.
Very good morning. For me, it's 7 p.m.
Okay.
But yeah, very good morning. What's the time right now? For you?
My time is 8:30.
It's
8:35.
9:35. 9:35.
Yeah.
9:35 morning. Right.
Yep.
Yeah.
Perfect.
It's a New Jersey Eastern Time.
Mm.
Oh. I'm in Minnesota. It's a CST time.
Oh, okay.
We have 1 hour difference.
Yep.
What about Saurav? Saurav, where are you right now?
Yeah, I'm in Connecticut.
Okay.
Yeah.
Okay.
So
That's
Eastern
again your
Eastern
EST,
time.
Eastern Time.
Yeah, EST. Yeah.
Okay. Very nice. So yesterday we had a discussion on KNN, K nearest neighbor, and today we are going to start with the very fantastic supervised machine learning algorithm, but that is support vector machine, and we can call it SVM.
Okay.
Okay, so let's continue the class. Let me share the screen. So we are talking about SVM. So SVM stands for support vector machine. Somewhere this is also similar with the linear regression or logistic regression, we can say. It is also inspired by the best fit line equation. So it is a supervised machine learning algorithm that's used for classification and regression. Regression. But basically this is very best in the classification, but mostly in classification. Now,
Yeah.
this algorithm is also inspired or following on the principle of best fit line terminology inspired by the best fit
Okay.
line concept. So if we understand very quickly about the SVM, see, let's say we have two classes of things. Okay. Let's say we have two classes of things, just like two classes. The first one is red ball, and the other one is blue ball. Okay, and which are basically scattered on the table. Okay, so I will make a very simple table. This is your table. So we have two types of color of balls here. The first one is red ball, which are scattered on the table. And the other one is blue color. Okay, so now what we will do, now our job is to draw a line that will separate the balls, means the red one and the blue one. So what I will do, I will create a line. This will be a somewhere the best fit line which separates the two classes, means this is blue balls and this is red balls. Now, so same concept, means so basically SVM do the same thing, but it does not draw any random line, but finds the best fit line or the best line that keeps two groups or classes as far as possible, means the distance that it keeps very far from the classes. Means if we talk about this class and if we talk about this class, so it will make the difference between two classes very high. So I will write here SVM doesn't just draw any random line just like we draw, but finds the best line. Best line for what? That keep two groups or classes as far as possible. In short, we can say that it makes let's say the color. It makes the difference maximum between two classes. So tell me, if the distance between two classes is maximum, then we can easily identify whether the new data is belongs to this category or this category. Means they are classifying these categories. Okay, so that's how, means the SVM is the main feature of the SVM is that it makes the difference between two classes very high or maximum, so that they will be classified in a simple manner. Okay, now the best fit line, when we are talking about any best fit line, or in SVM term, this is called what? This is called decision boundary. Best fit line called decision boundary. So if I draw a very simple diagram for the terminology that is used in SVM, so if we have two classes, so these are the two classes, and now what we are doing, we are drawing a line. So basically, this is what, this is your best line, or we can say this is your decision boundary. Now, there are too many things. There are two more things. That is what? These are the marginal plane. That are nearly closely to the data points. Okay, so we have, these are the data points, and these are the marginal plane. So basically we have two types of marginal plane. But first of all, this is your marginal plane. And these data points which are closely to the marginal plane, that is called support vectors. And basically they play a very crucial role when it comes to classification. Why? Because these data points will decide, these support vectors will decide whether the difference, or whether the distance of data points from the marginal plane to the best fit line from one class to another class is very low or very high. So these support vectors are very important, and they are closely to marginal plane. Now we have two types of marginal plane. The first one is soft marginal plane, and the other one is hard marginal plane. soft marginal plane. The other one is hard marginal plane. So soft marginal plane means plane with some errors. Errors means the data points are closely overlapping. Points are closely overlapping. Are you able to read my writing, or I need to clear it more?
Yeah, I
At
can
times it's a bit difficult, but some of them we are able to read it.
Yeah, if you feel like that, you can quickly say me, okay? Now, the hard marginal plane. Hard marginal plane is just opposite to the soft marginal plane. These are the marginal plane which has no any kind of errors. So this is what without any errors. Now, what does it mean by errors? See, if we have a data points which are nearly to the decision boundary and which are overlapping like this, like that. See, so this is what, this is your soft marginal plane. This is your soft marginal plane. And hard marginal plane means without any error. The data is clearly separable. Means there is no any overlapping based on the data or the data points. Okay, for example, these data points. See, these data points, they are not overlapping to each other. Okay, so when it comes to a very clean data, when it comes to a very linear separable data, so that SVM will do very good on that. Okay, when it comes to a model building. But what if I tell you, if your data is very noisy data or messy data, means unclean data, okay, then we have some parameters to clean it or to work on that, just like C parameter. Okay, we will discuss on that. But the thing is, if your interviewer asks you what do you mean by soft marginal plane and hard marginal plane in terms of SVM, then you can say hard marginal plane means without any error, means the data points are not overlapping to each other. Soft marginal plane means there are some data points which are overlapping to each other and they are closely to the best fit line. Okay, so the main purpose of SVM is to maximize the distance between the two classes with the help of marginal planes. Okay, by using decision boundary. Okay, so this is what, this is your decision boundary. Clear, everyone? Then we go for the terminology that is used in
No,
under
sorry,
this,
Miss.
like a
Actually,
perfect
I'm
plane.
having little doubt. Sorry,
Yes,
I didn't get this two particular things regarding this class. Just can you go a little bit faster? Briefly, just briefly, please.
I mean faster. What
Means
do you mean, sir?
faster means I mean to say just go through the last two topics in brief. I just get
Okay,
an overview. I didn't get it. That's why.
okay.
Okay. Thank you.
The
Sorry.
soft marginal plane mean or the hard
Yeah, both
soft.
both of this thing.
Okay, okay.
Starting with the marginal plane. What is this marginal plane and soft margin and hard margin?
Okay, okay. See, the marginal plane means it holds the data. It holds the data that
Hmm.
is closely to the best fit line. So this is your decision boundary, right? And it
Hmm.
makes a very simple dotted lines nearly to the classified data points. Like this is a class, this is the class, and this is the class, right? So it makes the marginal plane to make the distance from one class to the another class, right? So
Okay.
if the distance is very high, that means it works, the SVM works very nice. If the distance is very less, then SVM will not work properly, right? So the main
Okay.
purpose is to make the difference
The
very
distance
high.
must be equidistance.
No, maximum means the distance.
Okay.
Let's say
Okay.
if we are comparing like the distance from 1 to 10. So
Okay.
the main aims for SVM is to make the distance closely to 10.
Oh, okay. Okay.
Clear?
Hmm.
Okay, just wait and
Okay, fine. Thank you.
once we complete means the whole topic, then you will understand easily what exactly the hyperplane, the support vectors, the maximize the margin. Okay, see.
So one more question. When we say overlapping of data
Mhm.
in the marginal planes, are the datas are overlapping to each other or it is on the marginal plane?
It is on the marginal plane, and they are also overlapping to each other.
Okay.
Okay.
Okay. Yeah. Okay. Thank you.
Don't worry. When we use a data set and we will apply some visualization, then you can understand how these are working. Okay,
Okay.
separation of the data.
Yes.
Okay, terminology used in SVM. Or basically, we can say that steps. The first one is hyperplane. Now, when we are in two-dimensional, this is called is a line, a simple line. Like what? 2D 2D means simply just like this table. Okay, this is your two-dimensional. Okay, now in 3D, it is a plane, and in higher dimensions, it is hyperplane. When you are working on the data set that have a multi-dimension means or higher dimension, that it is called hyperplane. Now, the second terminology is support vectors. Now, support vectors are these are the points. These are the points closest to the line from both the group. See, these are the support vector which are closely to the line at the left side and the other side also. Okay. And basically these points are really important because they decides where the lines goes. So that is why it is called SVM, support vector machine. So the main part of this SVM is support vectors. Why? Because these data points actually decide what is the best fit line. Okay, so these play a very crucial part when it comes to decision boundary. And the third one is maximize the margin. So basically SVM tries to keep the distance maximum between two classes data points or the marginal planes. Marginal, or you can say or between the marginal planes, left side and the right side. Now there is a problem. Now the problem is this is just for when your data is linearly separable. Okay, see, like this, the data is separable. Now this is a class 1 and this is the class 2. Now what if I tell you, or what if I ask you, if the data is not perfectly separable? Now your data is very noisy. Okay, just like what? Your data is like this. We have two classes and these are the two classes and these are the data points. Now the problem is how the SVM will find a best fit line. Is this the problem? Tell me.
Come again, sir. Didn't get you.
I mean, if your data is look like this, is not perfectly separable, just like this. This is not perfectly separable. Means they are mixed up of the data. This is the class 1 and again this is the class 1, right? So now is this a problem with the SVM? Now the
Yes,
condition
we
is
can
how
say.
how SVM will find the best fit, or how it makes the best distance boundary, right? So basically we have some parameters, or we can say we have two hyperparameters. We can say these are hyperparameters. Okay, so once we pass these two hyperparameter with a very ideal number or ideal value, so it makes very easy to find the best fit line under this type of data. And that is what, let me write. So first one is soft margin, and in soft margin basically we provide the value of C, and the other one is kernel. So we use some kind of kernels, just like RBF, radial bias function. So it forms the it transforms the data from noisy to separable without using too much mathematics. Okay, now let me write here. The condition is, what if the data is not perfectly separable? Then we have two hyperparameters. The first one is soft. We fix the problem of soft margin. And you know what exactly the soft margin? Soft margin means having some errors. Okay, so soft margin. Let's say if the data is messy but mostly separable. Okay, so SVM allows a few points to be on the wrong side of the line. Just say so it's say, okay, you can make a couple of mistake. For example, these are the mistakes. Okay, like these are the mixed up of the data. They are classified with each other. But soft margin will allow, okay, you can make some mistakes just like this, the data we have. So there is a penalty for these mistakes, which is controlled by a parameter which is called C parameter. Okay, or we can say the hyperparameter. So we provide hyperparameter C, and we provide some value, so it can control these mistakes or these errors. Okay, so we have a parameter called C. So I can write here SVM have the parameter to manage the errors or noisy data with, or we can say, which is controlled by the C. So if we put the value of C very small, so like small c means more mistakes can handle. And big value of C means fewer mistakes are allowed. So we tune the model by applying the value of C in soft margin. Okay, so when we use SVC, means support vector classification, and we provide the value of C, then it can handle these mistakes or it can handle these errors. Now the other one is we are talking about two hyperparameters. The first one is C parameter and the other one is the kernel. Kernel. So for this, we have RBF, which is called radial basis function. So basically what it actually do, it transform the messy data or noisy data into uh, into something separable without using too much mathematics. Okay, just no need to go inside that. Basically, we have a separate, SVM. In sklearn, we have a SVM classification and regression part that we have so many hyperparameters in that, and we will go for we can go the website and we can check so many hyperparameters and the value we have in that. Okay, so no need to go that. No need to go deeper in that. So basically, overall, if we write an overall step which is followed by the SVM, that is, if I am concluding this, the first one is which actually SVM work on that, analyzing or watching the data carefully, then finds the best hyperplane that separates with the widest margin. Okay, means it keeps the difference maximum. Okay, then right after this, it use support vectors to lock that hyperplane. Hyperplane in actual place. And the last one is, the last step is, if the data is noisy, just apply the hyperparameters.
That noisy means not linear or something?
Not the linear. Okay.
Okay, non-linear.
Okay, just like this. I have drawn this. This is not the linear separable. Okay. Clear, everyone? So I'm
Yes,
going
yes,
to-
now clear. Good.
now I'm sharing this file. Or I think I can share at the end of the class, okay? Because what if I tell you that, I mean, we have to use some more functions on that, that's why. Okay, so it will make a very single page or a single PDF. Okay. Now tell me, is there any question that you want to ask? See, this is the overall, this is the game of hyperplane and the decision boundary. Basically, it's inspired by the best fit line. Okay, I'm not going to explain what exactly the mathematics using this because we have already seen mx plus is equals to mx plus c is equals to 0. Okay, so this is the mathematics that is using in SVM or SVC.
So sorry, I have a quick question. So suppose
yes.
let's assume that we have a linearly separable data in two-dimensional plane.
Mhm.
When we calculate the margin, are we calculating the perpendicular distance from the decision boundary to each of the points, or like how is the margin calculated?
See, these margins are totally based on the support vectors. Okay, basically they find a gap from first class and the second class, and then it will draw a margin, the best fit line or the decision boundary, and around this decision boundary it also makes some marginal plane which is classified into two plane, that is called soft marginal plane. So most probably we have to keep our marginal plane as a hard marginal plane. Okay, hard marginal plane means the data that you are using that is separable, or the SVM is working good on that. Otherwise, if you have a soft marginal plane and if your data is too noisy, then we can apply the hyperplane. Now the main thing is, how can the distance be calculated? With the help of Euclidean distance and with the help of support vectors. Why? Because these support vectors will be responsible to find the distance between these two marginal planes, the left one and the other one. Okay.
So the marginal planes are always parallel to the
Yeah,
decision
they are
boundary.
always parallel.
Okay.
Okay.
And the margin means the distance between two marginal planes.
Yes.
Okay.
See, somewhere this will be parallel to each other. See, you can see for the first. So this is also class 1 and class 2, and these are the support vectors, which actually is responsible for uh, making the marginal plane. Okay. See, and we can take one more example. See, if we check this type of data, somewhere the data is noisy here. Why? Because the line is The line is somewhere in curve, not in the straight line, and the data points are overlapping to each other, and some of the data points are in left side and some of the data points are the other side. So this is somewhere the data is non-separatable. Okay, and we can see some more examples of decision boundary. So overall, this is the main funda of that. Okay.
Okay, thanks.
Yeah. Now just do one thing. Just make a new collab file. 79. Okay. So basically for SVM classification model, we are going to use a data set which we will import from the library, sklearn library. Okay. And that will be the kind of classification data set in which there are three varieties of flower, which is basically called iris data set. Okay. Let me introduce the iris data set that we are using in this model. Iris data set. You can use this data set from the Kaggle, from the sklearn library, from the Seaborn library. Okay, this is available anywhere. Now, see, these are the type. Basically, we have three types of flower in that. The first one is versicolor, the other one is iris setosa, and the third one is virginica. Okay, and basically based on the petal length and petal width and the sepal length and the sepal width, based on the four categories, means we have four input columns. So we will be classifying based on these based on these four input data. We will classify that this type of flower, basically this data belongs to which type of flower, means the versicolor or the setosa or the virginica. Okay. Basically, this is somewhere we can say the data we are using. Basically, in this we have three types of flowers. The first one is setosa type of flower. The first one is setosa. It will look like this, and versicolor and the virginica. And based on the petal length, sepal length, petal width, and sepal width, we will classify whether this type of flower belongs to setosa type of flower or the versicolor type of category or the virginica type of category. Okay, clear with the data set?
Yes, yes, got it.
Okay. Let's create a new collab file. SVM flower classification. Okay, so in this project, we are going to use Iris dataset. Now, how we will import this dataset from the sklearn library? So the main I'm going to write here, load the dataset from the sklearn library and frame the data. Because when we import this data, that originally it is in the form of arrays. Okay, so we have to organize that data and we have to convert into data frame. So that's why I have written here, frame the data. Uh, and if you want to check the list of the data sets, so first of all, import sklearn dot datasets as dataset. Just run it. And simply I will write list. So simply print dataset dot underscore all and then double underscore. Just run it. Let me do one thing. Just remove the print function. So basically this is the list of the data set. So we have to find where is load iris. See, this is the data set we are using, load iris data set. And see, just below to this, we have breast cancer data set that we have already used yesterday. Okay, so it has so many data set you can use for your practice. Diabetes data set, we have also the digits data set. Also, we have some files data set. So many data sets we have. Now, import pandas as PD and import numpy as np. Also do one thing, ignore the warnings. So we have a code import warnings dot import warnings, and from warnings import filter warnings and just ignore it. Now we are loading the data set. Loading the iris dataset. So from sklearn dot datasets import load underscore iris. Let me check, is this the name? Yes. Just run it. Now you have to make an object for the dataset. So I'm writing iris is equals to load iris, load underscore iris. Put the parenthesis and just run it. Now when I write iris, okay, this is somewhere very hectic to understand. Just do one thing, because we have so many lists in that. Okay, so I can write check the content or the list of the categories. So just simply type dir. Dir means directory of iris. Just run it. So basically we have some information in these attributes. So we have data, then we have data modules, then we have feature names. Feature names means the column names. Okay, and then we have a target column also, and then we have a target names also. Okay, so we will be using some kind of categories to build the perfect data set in that. So we will use data, then we will use feature names, then we will use target, and then we will use target names. And see, if you want to check feature names, if you want to check the feature names, check the feature names. So what I will write, I will use iris dot, just copy this, just paste here and just run it. See, we have 4 variables: the sepal length in centimeter, sepal width of the flower in centimeter, petal length of the flower of this in the centimeter, and the petal width also. Okay, so we have 4 column names, and these are the column names. And basically, when you put iris dot target, so it gives you the target name also. I mean the target data also. Okay, and I think in data we have the data related to feature names. When you check iris.data, iris.data, just run it. See, basically this is the data set. So we have 4 columns here. See, 5.8. I mean, this is the first value. What is it? 6 point, then comma 2.7, then comma 5.1, then comma 1.6. So total how many columns we have? 4 columns. And here's the list of 4 columns: the sepal length, the sepal width, the petal length, and the petal width. Okay, so these are according to the data. Clear, everyone? I am going to share this file in the chat box. Just complete it. We are taking a very short break here, then we will continue.
Okay.
And if you want to check the attributes, so you can just put iris dot and just the attribute, and you can check the data set that you have in these categories. Okay, everyone, back to the class. Or still taking 10 minutes break?
Yeah, we're back.
Okay. Okay, so we were just talking about the data set, and we were exploring the data set. And we can do one more thing. We have already checked that the feature names. Now we can also check the target names. Check the target values. So for this, what I will write, iris dot target names. Just run it. See, we have it is in the form of array, as I told you. In a list, we have Satosha, versicolor, and Virginica. So three categories we have in the flower types. And if you want to check the shape of the data set, the whole data set, check the shape. Tell me how we can check the shape of the data set. Data set. Tell me what would be the code to check the shape of the data set.
iris.data.shape.
Iris.data.shape. Yeah. So we have a data and we are just applying the shape attribute on that to check the shape of the data. So total 150 rows and 4 columns we have. Okay, so we have already seen that in the feature names like sepal length, sepal width, petal length, and petal width. Okay, now if you want to check the target values, check the target values iris dot target. So these are the target values. Actually, it is already in the encoded format, right? So 0, then 1 and 2. Now, what we are going to do is, because the data set is in the arrays form, so we will be organizing this into data frame for better thing. So just do one thing. I'm going to put inside the df. So df is equals to pd dot data frame, and what I'm going to take here inside this iris dot data. So I have taken the data set and I will just pass columns is equals to iris dot feature names. Feature underscore name. Let me check the feature names. Okay, it's names. Feature names. Okay, just run it. Check the data. So df dot head. So see, now it is in organized form. So this is sepal length in centimeter, this is sepal width in centimeter, and petal length and petal width. So basically this is your input data. Okay. This is your input data. So either you can go for no need to split the data set. It's already splitted. And we have one more column you can put inside this input data, means x is equals to df dot head. I mean x is equals to df dot copy, and you can put the target column inside the y variable. Okay, but we are not using this. Actually, we have to insert one more column, name as target. I will write here. Now we will add the target column inside the data frame, means df. So at the left side I will define the name of the column, that is what, target, and just iris dot target. Just run it. Now check the df dot head. See, now we have target column. Okay, now it is already encoded 0 1, so no need to encode anything. And if you want to check how many
I am
categories we have with
getting,
this. Sorry,
I am getting df is not defined.
df is not defined means just check this line. df is equals to pd dot data frame iris dot data, and the column is equals to iris dot feature names.
Okay, I think I see the reason why. Let me see. No, P-A-T-U-R-E. Yeah, I'm still getting error.
Show me
df
the screen.
equal pd
Show me
dot.
the screen.
Okay. Um, one second. Let me see here. Click share, share, share. I don't think I see. I have the option to share.
You can go and check in
Okay, I got
Zoom
it.
application. There is a upward arrow, green color arrow. Okay.
Right here.
Give me the access.
The data frame. It should be,
Yeah, D should be capital and F should be capital. Okay. And F should be capital. Yeah. Now just run it. Module Pantra has no attribute data frame. Oh, okay, okay.
yeah,
Just make it clear. Okay, it's data
yeah,
frame.
yeah,
Just
data
remove
frame.
just remove the last.
Oh.
Okay. Oh, MEME. Okay, now just run it. Okay, see, now it's okay.
Okay, thank you.
Oh, perfect. You can stop the screen.
Let me get back over here. Okay, we should be good. Hello, are you talking? Because I don't think you are audible.
Oh, I'm sorry. So
Okay.
if we check value counts, if we are checking the value counts for the categories, so see total 50 values for the first type of flower, total 50 values for the first type of flower, I mean second type of, and means the three types of flower we have, and 50-50 are distributed. Okay. Now we can do one thing. So right now, I don't know 0 stand for which category. I don't know. So I can add one more column in which I can find out the corresponding flower type of the value in the target column. So we have three types of flower, and we have to assign them according to the target value, right? And we can do with the help of lambda function. So I'm going to use lambda function, which will assign the categories for 0 and 0, 1 and 2. Okay. And it will calculate how many categories we have in this. Assigning the name of the flower with corresponding values in target column. So df, just define the name of the column. So let's say flower underscore type, and df dot in target column, and just apply the lambda function. So we will write a parameter that is x, put the colon, and just apply iris dot target underscore names, and inside this just pass x. So what it actually do, this x will go inside the target column, and it will apply according to the target names. And just run it. Now if you check df dot add, now see it has assigned Setosa and I don't know for which type. So we can use one more column so that we can understand easily. See, we already know that for first 50 we have zero type of flower, then for next 50 we have second type of flower. So if we call df from 48 to 52, so at the 49 position we have almost 50 setosa type of flower, and starting from 50 we have versicolor, and same we can check for like 98 colon 102. See, versicolor and the virginica starting from 100 to 150. Done this much, everyone?
I have a quick question.
Yes, yes, Saurabh.
So when we applied the lambda function, we assumed that the target column, which contains 0, 1, and 2, and
Mhm.
the target names Setosa and the other two. So 0 is assigned to Setosa, 1 is assigned to Virginic or whatever.
Yes,
So
yes,
we,
yes.
we, we assumed that that correspondence already exists in the data set, right?
See, we are not assuming, it is already in the proper way, like in first position and the second position and the third position. So we are just applying that target names in the target data. Okay.
Okay. Okay.
Now we can visualize our data also, how our data is separable. So I will write data visualization part. And in this, first we will separate the variety of flowers and defining new data frames variable that helps to distribute the categories for visualization. So what I'm going to do is I will write df0. So df0 stands for first category, and I will take first 50 values. Same for df1, and that is we will take from 50 to 100. And in third type of flower, generally use df and from 100 to all. Just run it. Now import the library. Import matplotlib dot pyplot as plt. See, what I'm going to do is I'm going to visualize for sepal. Okay, for sepal length and sepal width, how they are distributed. And then you can apply the same thing for other part of the data also. Okay, visualize for the sepal. So first of all, plt dot with the help of scatter, and from first type of flower means from df0 I am taking a sepal length. So just do one thing, just copy this, Control C, Control V, and right after this, from df0 means from first type of flower, I am going to take sepal width in centimeter. So sepal width in centimeter, Control C, paste here. And for better visualization, I am going to take the color. Color is equals to red. Okay, and for identification, I'm going to take marker is equals to, just take diamond shape, and just do one thing, just apply the same thing for the second type of flower. Control C and Control V, and instead of df0 just put 1, and same here, and now plt dot x label. So in x label, this is what sepal length. Sepal length. In plt dot y label, this is sepal width. Okay, and just simply plt dot show. Okay, all these things are red. Okay, just do one thing, just make it change, just make it green, or just make it magenta, and just take this 4 type of categories. This is, oh, see how this is separable. Okay, so this is sepal length and this is sepal width. And you can do one more thing, plt dot legend. Legend is not working here. Okay, just leave it. And similarly, you can visualize for petal also. Okay, but you can do right after the class. We don't have any more time to do this. We have to build our model. Okay, clear everyone?
Yes, yes.
Okay, what I'm going to do is split the data into X and Y. And you can also do the same thing. Okay, now you are the champion in this. X is equals to df dot drop, and if I drop the columns is equals to I want to drop the target column and the flower type that I have recently added. So this is your input data. Let's run it. Now y is equals to df and target column I want. This is your output data. Now applying print as split. From sklearn dot model underscore selection import train underscore test underscore split as split. Let's run it. So x underscore train comma x underscore test y underscore train comma y underscore test is equals to split this apply x and y test underscore size is equals to 0.8 and random underscore state is equals to 42. Just run it. Now the data is splitted. Now we can print the shape x underscore train dot shape underscore test dot shape and y underscore train dot shape and y underscore test dot shape. Just run it. So 34, 124. I think there is some
Test
mistake.
size 0.2. Test size.
Train size should be 120, right?
Yeah. He-
What mistake I have done here?
Test size you define as 0.8 should be 0.2.
Okay. Now it is correct. Now building the SVC means support vector classification model from SVM algorithm. So from sklearn.svm import SVC and just create an object. So model is equals to SVC, the parenthesis, and just run it. And I think we missed something. We missed the data transformation, I mean data normalization part. Why? Because we have 4 variables, right? 4 input data columns. Okay, you can do one thing. Right after the class, just do this process from yourself, okay? Just apply the data normalization. Okay, standard scalar.
Okay.
Clear, everyone?
Yes.
Yeah. It makes you help you to know.
Oh, yeah, yeah.
Now, training the model. So model dot fit, and I'm just passing x underscore train and y underscore train. Just run it. So we got SVC. And you can also apply the kernel, like, see, I'm going to share with you. SVC hyperparameters. Hyperparameters.
SCV or SVM hyperparameter?
SVC means a means a support vector. Okay, sorry. SVC, support vector classification, classifier. And just open the first link. See, by default, the C value is 1.0. Okay, and the kernel they are using RBF kernel. We can use linear kernel also. Why? Because we are using the data that is linearly separable. Okay, gamma scale and then single and then coefficient value. Okay, all these values are predefined. Okay, decision function shape. See, the parameters that we are using, regularization parameter, the strength of the regulation is inversely proportional to C, must be strictly positive. The penalty is a squared to penalty for an intuitive visualization for the effect of scaling of or regulation. See, no need to go this terminology, technical terminology. What I have said, this C parameter actually helps you to minimize the errors. Okay. And we have some more kernels like linear kernel, then we have a RBF kernel, then poly kernel, then we have a sigmoid function also. It is just like acting as a functions. Okay. So how we can use this? So like this, here we can apply C is equals to 1 and kernel is equals to linear. Okay, just run it. What happened? Let me check. Is capital. Okay, and when I run this, parameter of S must be as strong as linear, polynomial, or sigma RPF. Okay, the spelling is wrong. See, it says C is equals to 1 and kernel is linear. Okay, now just check the accuracy. So model dot accuracy, model dot accuracy, and actually we can direct apply score x underscore test, then y underscore test. Yes, so now when we apply C is equals to 1 and the kernel is equals to linear, so it says 1.0 means the 100% we are getting here. Okay, you can make the prediction also. So y underscore pred is equals to model dot predict, and just pass the variable x underscore test, just run it, and when I run this y underscore pred, just run it. So this is what, this is your predicted output. And we can compare with the actual output. So what is your actual output? Y underscore test. So it says 1, 0, 2, and my predicted output is also saying 1, 0, 2. So no need to compare. See, already it's giving me 100% of accuracy. Clear? And we can do one more thing. We can predict the new flower. So model dot predict, and inside this I will be passing an array of the input data. Say for example, all is in the form of float values. So let's say 2.5 sepal length and 3.5 sepal width in centimeter and 1.4 petal length and let's say 0.5 for petal width. Okay, and when I just run this, it says 0 means it is somewhere related to first type of flower, that is Setosa, I think. Clear, everyone? Am I audible to you?
Where did you get the 2.5, 3.5, 1.4s, and
I'm just taking
0.
random values.
Oh,
Okay.
okay.
Because I need to predict the new flower.
Okay.
So based on these input features, my model is saying that it belongs to 0. 0 means the Setosa type of flower it is. Okay. Now tell me if it is clear to all of you. Then I'm going to provide the quiz.
Yeah, a quick question.
Yes, yes.
If the data is linearly separable, then accuracy will always be 100%, right?
Yes, yes. Somewhere, yeah, the accuracy will be 100. No, basically one more parameter is responsible for this. Actually, it is also depends upon the size of your data. Okay, because we have a very less data set. Okay, but the concept is same. You can provide, if you are not getting some good accuracy, you can apply some hyperparameter tuning. Okay, like changing the value of C, changing the kernel. Okay, so first you have to
Okay.
visualize your data, that how your data is separable or non-separable. Then you will decide which kernel I have to take here. Okay, you can use RBF also, you can use linear also, you can use poly also. Totally depend upon the data. Okay.
Okay, but I mean, if we find that data is linearly separable, then it will always be 100%, right? Not the other way around, but
Yes, yes.
okay. Yeah.
Okay, everyone. So I'm just sharing this file once again in the chat box, and I'm just providing you the link of the quiz. And while you are completing this, I will convert the class note into PDF and I will just provide in the chat box.
Okay.
First of all, this is the link of the collab file. And just hold for 2 minutes, okay?
Okay. Okay.
Okay, everyone. So I have just connected to the management team, and they will tell that they have not prepared that quiz. Okay.
Okay.
Okay. So we are just going to end this class. Okay.
Okay, fine. Thank you. Thank you.
Okay.
See you
Thank you,
next week.
everyone.
See you on Saturday.
Yeah. See you on Saturday, and just keep the learning up. Okay.
Okay. Thank you.
Azhar, please
Nice.
share the class notes.
Can you
Okay.
share
Yes. The
notes?
class note. Okay.
Okay.
Sure.
बस 2 મિનિટ મિયા ને હા 2 મિનિટ
Okay. So see in the chat box.
yes got it
Yeah,
Okay.
got it. Thank you.
Thank you.